Hello there YouTubers and welcome back to my programming tutorial series on OpenGL. I'm your host SuperDavo001 and today we're going to be looking into shaders. Now, what are shaders? Basically, OpenGL when used automatically will draw things in a certain way. It'll start off with the vertices, you put them in, it then transforms them via the matrices, which you'll see later on. And then after it's done the matrices, and you've probably already seen the model view and projection matrix, they're what you translate, rotate and use ortho and perspective on. But then it uses the matrices to get a special type of coordinate called something like homogeneous or something. It's really weird, I don't know how to pronounce it, but once you've done that, then it goes through to the screen where it creates a pixel before sending it off. Now this process with shaders, you can modify it. So instead of doing this matrix stage, you can divert it round to a vertex shader. You can divert it round using a vertex shader to change how it does that, and then bring it back. And then before it does things with the pixels, you can change that as well with a fragment shader. So it can change what it's drawing. So you can basically change where the vertices are, and you can change what the pixels look like using shaders. And why is this useful? Too many reasons. Normal mapping. You've got normal mapping there. You've got shadows. You've got ray tracing. You've got absolutely everything. You can't have a game with good graphics without shaders. It just doesn't work like that. So, you know, I'm starting from the program I had last tutorial, which is this one, this lovely little triangular thing, and we're going to be working from there. Now, just something we're going to need really quick. If I just slide over here, this is a project I've made before, but we're going to need the GLEE CPP and header files. Now, where do you get them from? Google it. Just don't Google Glee, because that's a sitcom. Google Glee OpenGL. The GLEZ extension library it's called, and it basically this gives you support for features of more recent OpenGL versions and extensions and stuff like that. So basically you can use a heck of a lot more with it. And it's available at this it's available at both websites actually, although the other one leads you to this one. And then at the bottom you can download the versions of it and stuff. Where is it? Which one? Yeah, it's one of them depending on what compiler you're using. Oops, that's my Twitter. Anyway, enough Twitter. Hopefully it didn't show too much detail there, but yeah, so we need these two, and now you could do something more complicated, but the simple way of getting these header files in place is literally just paste them. And then slide back over here, and then in code blocks anyway, I go to project, add files, find GLEE, and then open. Add them to both of them, and now it's 10,000 lines of code or so, but it is useful. GLE. Now, when you include it, always include it before gl/gl.h, or it will not compile. So include GLE.h. Well, and ladies and gentlemen, that was accidentally my desktop. I keep clicking in the wrong place for some reason. I don't know how I did that. Yeah, so now we have GLEE. And the next thing we're going to do, and this I'm afraid is going to be yet another example of taking a while, is to create a class for shaders. File, new, file. First let's create a header. Let's call it shader. Sorry if you can't see that, but yeah, I called it shader.h. Now inside this we are going to need a class called shader. And let's see. So I've got private and public. In the private, I might put in. I'm going to put in a couple of functions. Firstly, I'm going to have. Let me see. I'm going to have load file, and I'm not going to do it like that. I'm going to have a semicolon. That will this one will return the file, and I'm going to need. Before I do anything else, I'm going to include some things. First things first, I'm going to include string. We're going to need string. I'm going to include the F stream, so that's for files. I'm going to include the IO stream, because that's always handy, and also I'm going to include gle.h. I'm also going to use the standard library, which is just as standard. So let's see. So we are going to need to load file, and that is going to have const chart file name, not a double pointer, and a reference to a string. After that, I'm going to have a function called that is unsigned load shader. Now you're wondering why I don't do these in public. That's because they're all gonna. That's because they're gonna get taken care of in the constructor. And load shader is going to need a string reference of source and a unsigned int mode, and that is, what was that? Oh yeah, that's whether it's a vertex or a fragment shader. Sorry, I'm looking at my cheat sheet, which is over here, because I couldn't print it out this time. Bit annoying, but who cares? So after that, I'm gonna have to add some files to public, and that is going to be. First I'm going to have a void. No, in fact, you know what, I'll do the void after. I might as well do the shader constructor, which is going to have a. It's going to have a char pointer for the vert source and the char pointer for the frag source. Don't forget, vert source is the source of the vertex shader, which moves the vertices around. The fragment shader works with pixels. Although you'll understand that more when we actually use the shaders. So then after that, we're going to have a destructor for shader. We are going to have a unsigned int get handle. Oh, and also that means in private I'm going to have an unsigned int that is handle. Now remember with textures, when we did glgen texture and we had a handle, it works similar for this, because that handle basically is how you get to the shader. So let's see. So then we've got get handle, which is going to be a really handy function, and then there will be some more functions, but for now these are the main ones, because after that we're going to have to deal with the uniform variables, and well, that's later's job. So now let's make this class into a class by adding a CPP file. Once again, I'm going to call it shader, so shader.cpp. If I can type it, shader.cpp, and I'm going to include the header file. I don't think I really need to include any more. I could include the others. Just simply copying off my cheat sheet there again. And once again, I'm going to be using namespace std. So now let's go back and grab some of these functions. Firstly, let's do these two. So just make it so that it's the shader ::load file and then shader ::load shader. So this is going to be more C++ than OpenGL, this first section, so bear with it. So first we're going to need an input file stream, and in equals, in fact no, it doesn't equal, it's just we set it to the constructor. So if in dot is open, and it just messed about with the brackets there just to annoy me. So if it's not open, then we can see out that the file and that's an F, not a C, just so you know. We should be able to work that out for yourself, to be honest. And then going to create a temporary char, and for now we're going to give it 300, but the problem is that's a limit. You could set it higher if you find there's issues. In fact, you know what, I'll set it to 500. So it basically creates a massive array of characters. Then while come on. So while the input stream is not at the end of file, so basically while it's still going, then in dot get line, and then to the temp string, and then the amount of room there is in it. So get up to 500 characters basically, and then the string, which is the reference string at the top, add the temp to it, add the temporary character to it, and then always add a new line, because it's always handy. So that's the file loaded. So that means that, so basically the result of load file, which is this string reference, will be used as the source for the load shader. So unsigned in ID equals GL create, oh jeez, hold on, equals GL create shader. Hold on, it doesn't seem to be detecting that function. That's got me worried. But it's going to be created according to that mode anyway. Let's see what happens when I try to compile it. Oh, it compiles fine, don't worry. I think a good way to fix that problem would be just to close code blocks and then reopen it. I'll do that in a bit, because it'll just speed things up. And now, next thing we're going to do is we're going to create a C-style string. So const char so basically that converts the string to a C-style string. So source.str. Oh my gosh, that sounds like a massive tongue twister. So after that, I'm going to do GL shader source, which requires the shader ID. It requires the C source, and it requires null. In fact, null's actually in capitals. So basically, I don't know what that last parameter is, but just leave it null. And then GL compile shader. That basically, it's like compiling a C++ file, only it's done in real time. And then for a bit of error checking, create an error, and then GL get shader GL get shader info log. This basically receives the information from the shader as to how it compiled. So ID, the amount of space in it, then null, then error. Now I might actually just before I do that, I might just actually no, that's not going to work, is it? Yeah, that's not going to help. I was going to try to do it according to the file name, but that's not going to actually be possible. Never mind. And then I can see out the compile status. And then after that I can just return the ID, which is the shader ID that I'm going to be using. So then, now to do let's create the let's create the constructor next. So once again we're going to need two file names for the sources. ID equals GL create shader mode. Oh wait, sorry, I was going down completely the wrong route there. I was actually redoing the load shader on my cheat sheet. I apologise for that. So let's see. So we are actually going to need a string for the source. This is the string where all the references are for. Oh my gosh. I'm glad I don't have to do the English exam anymore. Just recently done it. Anyway, so the next thing is to run the load file. And to do it with the vert source. And then the source. After that, hold on, let me just look at something. And back, there's something I missed. I've just noticed it because we're also going to need handles for the vertex shader and the fragment shader. Just a brief fix. Oh fudge. Yeah, it appears there's something wrong there. I'll look back at that later. Hold on, let me just... There. So let's see, load file. Then the VS equals load shader. Now I can just use the source and then GL vertex shader. And then just set that to null, and after that I can load file again. Hold on, it's kind of drifting out of view, isn't it? I'll just move that down. Load file. Load file frag source. fs equals load shader. And then this time it's GL fragment shader. And after that, now we need to create the actual shader program. So now we're going to do handle. Let's see, handle equals GL create equals GL create program. Now, I didn't really adequately explain what a shader program is. The shader program is basically the vertex shader and the fragment shader put together that can run as a actual pair of shaders. And so GL create program, then you need to attach the shaders. GL attach shader. I actually spelt it right. Pardon me. Attach the shader to the handle and the vertex shader. Well, attach the vertex shader to the handle. Then do the same thing again for FS. No point in really writing that again. And then after that, you have to GL link program. Why doesn't it like that? But link it according to the handle, and then after GL link program, then GL use handle that. That essentially, actually I don't know why I did that, but anyway, I bind, for some reason in my code I bind it and unbind it. But anyway, this is how you bind it. GL use program, and then once again binding 0 unbinds it. Speaking of which, I still have to do the bind shader and unbind shader code. I probably should have included that in here. So let's see, I can copy them over now. Oh, and I'll also copy the destruct while I'm going. So I'll take the shader colon bit, shader destructs, shader bind, shader unbind. First I might just do this one first actually, because I can. So firstly you have to detach the shade, so this is where you delete them. Firstly GL detach shader, and that's the vertex shader. Do the same thing for the fragment. It's basically so that when you delete the program it doesn't fudge up these shaders. And after that you can GL delete shader, the vertex shader, and then do the same again for the fragment. And I did that by accident. And then GL delete, and then delete the program out of the handle. So that's the destruct done. That was quite easy. Once again, GL use program, use the program at the handle, and then to unbind the shader, GL use program 0. So that's the majority of the code, but we're gonna need to do a little bit more later. I'll show you how to do it later, because we're gonna need to set up the uniforms, and well, for now we can live without that bit of code. In fact, you know what, I'll do it now. I'll do it in the header. But basically, a uniform variable is a variable that's passed from the C++ code into a shader, and it is really handy to have these. So I'm going to create a lot of functions here, but I'll only explain a few of them. So I'm going to first do set uniform float, which basically allows you to pass a float into the shader. Now I'm going to have a char pointer of the name, so it's the name of it, and then there's the, let's see what else there is, the float of the value. So this uses GL uniform 1f. Now number 1 is the number of floats, because you'll also be using vectors, which just to give you 2 seconds explaining vectors. A vector is the amount in x, the amount in y, and the amount in z. So it's like 3 numbers in one. Or it could be 2 as well. It can be 2-dimensional, 3-dimensional, 4-dimensional. It can be infinite if you really want. But if you have a vector to there, then it would say in x like, say 3, y would be about 5, and then in z it's 0. So it's just 3 numbers that define a vertex really. And you can have other ones as well, such as colour vectors, RGB, and you'll see. So, but for now we're just doing the floats. GL uniform 1F. GL get uniform. Get uniform location. Then, what were the parameters for this? Just give me a second again. Done it. Okay, so I was struggling to remember which parameter was first, because there are two parameters. First, you need the handle of the shader program. Then you need the name of the variable in the shader, which is name. And then once you've got the value from GL get uniform location, you simply get the put the val in there. You'll see how we use uniforms later. And then there are other ones as well, such as I'm going to do a set uniform float 2, which is a 2-component vector. So I'm going to put in a second val. Now I'm going to do this again for vectors 3 and 4, and then I'm going to do the same for integers, so I'll be back in a moment. There we go. So now I've set up the integer vectors and the float vectors, and I should probably just change that to 3 and that to 4. So there we go. So it's GL uniform 1F, GL uniform 2F, GL uniform 3F, and GL uniform 4F. For the integers, it's 1i, 2i, 3i, 4i. I'm also going to create another one, which is set uniform sampler. A sampler is basically an object that samples a texture. So, but you pass it in the same as an integer, because it's the integer for which texture you're using, because you can have several textures active at the same time. But I'm going to have a char star name and then a int val. So then I'm going to it's another GL uniform 1i, then GL get, I'll admit this is the same as the thing, the set uniform int. So GL get uniform location, handle, name, and from there I can then say it to the file. So that's all the shaders set up. And now it's getting kind of dark in here, so I'm going to just turn the light on. I'll be back in 0 seconds once again. Boom. If only it was that easy to turn lights on in real life. But yeah, so now, by the looks of it, that is our shader class. Now we need to actually create a shader. I'm sorry about the length of this tutorial, but it had to be done, because shaders are seriously useful. So let's see. Let's add this to the project. This is going to be our vertex shader. I'll create a folder called shaders because it's always nice to have shaders in one place. And I'm going to call this one vertex.vert. The extension at the end doesn't really matter, but I usually call them vert and frag because it's just a good name. And now this, I'm afraid, is going to move on to a completely different piece of OpenGL. But it's a fun one, because this is GLSL, and it's a completely different language, but it's very similar to C++. It's not much harder, don't worry. So the version for this code is going to be 120, because that's the latest version that we can use GL Vertex, which is really useful, because otherwise you'd have to use an attribute variable, and well, you need VBOs for them, and we haven't gone through them yet. But don't worry, we'll get there. So the void main first, that works identically to C++. Now the first thing we're going to have to do is to set the GL underscore position equal to... There are two ways of doing this actually. There's F transform, which basically transforms the position based on the matrices. And then there's also a second way, which is to do GL underscore model view projection matrix start GL underscore vertex. Now that one looks a lot more complicated, but it's useful to know that, because it basically transforms it into something which it can read and map to pixels, basically. So this first shade is not really going to do much, but we'll modify it to do some simple things after that. So once we've set that, we can set a file new... oh, for just sake. File new file. Once again, it's going to be an empty file. This is going to be our fragment shader called fragment.frag, although again I'll put it into here. And then again, hashtag version 120. It's always best to put that there, you don't have to though. So let's see, void main. Now this one, you're going to have to set, instead of setting GL position, this one requires you to set something called GL frag color. Without the S. Now first we're going to just set it to a simple value of vec4, because GL frag color is a 4 component vector. And don't forget, a vector contains 4 values, but actually a color vector, I'll just tell you quickly, is a different 4 values. It's red. Oh, need the brush. It's red, green, blue, alpha, and these are all stored as values between 0 and 1. So basically, if you have alpha's transparency, by the way, it's not color. Alpha determines the transparency of the pixel, but just leave it at 1 for now. Trust me, it's safer. But if you set red, green and blue to 1, 1, 1, you'll get a perfectly white color. If you set red, green and blue to 1, 0, 0, you will get a red color. If you set it to 0, 1, 0, you'll get green. If you set it to 0, 0, 1, you'll get blue. But you can also set it to things in the middle. So 1, 1, 0 will give you yellow because it's red and green, which is kind of a reference to an old game I made. If you set it to 0.5, 0.50, you'll get a darker green. If you set it to 0, 1, I think you'll get cyan, which is kind of a lighty bluey greeny sort of thing. But for now, let's just set it to red. So 1, 1, 1, 1. In fact, no, that's white. So this, for now, is just going to be a very simple shader, but we're going to do more with it soon. But first we've got to load it in. Shader.h. Now create a shader pointer to simple shader. And then the init function, shader equals load, no, not load shader, equals new shader. And don't forget, it's constructed with the vertex shader location, which is shaders slash vertex.vert, then shaders slash fragment.frag. So that's the shader loaded. Simple enough. Now let's see. Inside the display function, we're going to do shader.bind shader, and then unbind the shader later on. Now we don't really need to unbind it at the moment, it'll be fine, but you know, it's always nice. So hopefully if this code all works, which it doesn't, then yeah. Oh right, I know. I called it simple shader, didn't I? Not just shader. Yeah, and there's still other matters to sort out. Invalid conversion. Hold on a second, let me just deal with this. Right then, error number 1. This GL shader source needs an extra component, which is the size of the C source. That actually sounds quite funny. But yeah, size of the C source. Just an extra argument there before the C source itself. Now after that, I have issues with GL detached shader, which I believe can be fixed by a little thing called knowing how to spell. Right, now it appears to have compiled. Let's attempt to run it. And it doesn't run. One more moment. Okay, let's try again. Just set that to 1. See if this works. Sorry, I've been looking for ages. By ages I mean about 5 minutes. Oh gosh, it's compiling the wrong project. And this one takes forever to compile because it's huge. It's that normal mapping thing again. I'm trying to get shadows working on it, but no success. But that's not important now. But what is important is that now that we've fixed that, the shader works. So what does it do? It basically tells it to transform the vertices into the correct position, and once it's done that, in the fragment shader, it sets the pixel automatically to red. And now, you're probably moaning at me now. So you're probably saying, look, I've spent forever and a day making this code to do just that, to make things red. You just wasted my life, David. You're an idiot. But no. Because you see, you can do a lot more with these things. Well, the next job for us to do is a texture. Is to add in a texture. And now remember I said about samplers, because we're going to have to set one of them in now. So a uniform, which if you remember rightly is, that is a variable which is set by the variable set by the the C++ file. And remember as well that sampler 2D, it's a sampler anyway, but it basically samples the texture. Sampler 2D. Now I'm going to call this, in fact no, okay, that went wrong. I'm just going to call it text. I don't really feel like calling it anything more complicated. So, from this sampler 2D, we're going to call the function texture 2D. And that takes 2 arguments, and one of them is the UV coordinate. How do we get the UV coordinate, you might say? We're going to need a varying variable. And what does the varying variable do? It's a variable that goes from the vertex shader to the fragment shader. And what's cool is that it interpolates the values, which basically means that in between the vertices it will kind of average them out. So we are going to need a vec2 UV. And now this UV is going to be equal to gl underscore multi text code 0 dot xy. Now this is the cool thing, you can set it to .xy, or you can set it to .xz, or you can set it to .yzxw or something like that. Although only wxyz, although some of them actually do RGBA, and some of them use ST as well. In fact, you know what, I'll use ST. It's probably STUV or something, I don't know, but yeah, so you take the x and y from GL multi text code 0, because it's only a 2-dimensional texture, not a 3-dimensional texture. Those are a lot more complicated. But yeah, so that's how you get the UV coordinate. And then you can simply transfer that over to here. So now I've got the UV in both of them. So now you're going to need a vec4. So vec4 color equals texture 2D, and it's the texture, which is the sampler, and the UV. And gl underscore frag color equals, I will just warn you that one object doesn't actually have a texture or UV coordinates, so it might glitch, but the important thing is the Jupiter one will work. However, we'll first need to set up that uniform, and you absolutely have to, for some reason, set the uniform, but only you have to say it every time the shader's bound. So that means I'm going to need to go into the display loop and do simple shader dot set uniform sampler. I believe I call it text, and set its value to 0 because it's texture 0 that we're using. Just remember the function GL active things like that. If you use GL active text to GL texture 0, it'll set the 0th, then there's 1, 2, 3, 4, 5 and so on. Although every computer has its limit and it varies. But yeah, hopefully now this will work. And wouldn't you know, it does. And congratulations, you now have a orbiting object. In my case, it's a photo that I took of Jupiter. And just to make it look a bit better, I'm going to remove the triangles. So for now, shaders can be used to mess about, but I'm going to be teaching you a lot more cool and complicated stuff as we go through. So there you go, there's a Jupiter. But as well, you can do things like, what can I do that's really simple and really quick? You could do it monochrome. Well, actually, you can use R for this. Of course, leave alpha as 1, don't forget. Just, you don't need to change alpha at the moment, it's weird. Yeah, now, that's what it looks like in monochrome. Although, of course, that's only the red part of the spectrum, which will be from the red part of the photo combined with the infrared part of the photo, but that's a topic for a space photo tutorial. So yeah, thanks for watching this. I apologise again for the length. But you know, it's well worth it. Now I'll just show you quickly some of the awesome stuff that my shaders have done. And it's once again running the wrong project, only this time it's the other wrong project. But oh no, it doesn't work, does it? I just remembered. It doesn't work when in full screen, so I won't be able to show you. I apologise. And oh yeah, that's weird, it ran into an error. Oh well. Again, that's a problem for another day. Yeah, so I've got this working now. And thanks for watching, and what will I do next video? I might try to show you lighting. I'll try to show you per pixel lighting, because lighting is really cool and really useful. It also gives you a good chance to do something with shaders that you can't do with anything else, so finally you'll be able to see just how good shaders are. So yeah, I'll see you then. Thanks for watching, and see you next time. Please subscribe and whatnot, because this series will keep going. And goodbye.